Hi, my name is Johanna Stewart, and this is my video report from my fifth lab of Physics 2211 on a falling spring. The purpose of this experiment is going to be to track the behavior of a vertically suspended spring as it falls under gravity. We will be comparing the predicted motion with the observed motion and understand the complex oscillating systems. As a preview of the results, the model manages to closely approximate the real motion of the system, and some key assumptions are that there are not going to be any surrounding forces affecting the motion of the system. This specifically means that we will not be taking into consideration any air resistance on the system. Some fundamental principles. Firstly, Newton's second law. We will take in that the net force is going to be the sum of the spring force plus the force due to gravity, which can be seen in the equation. And another concept important for the experiment is that springs in series behave a little bit differently. A series of springs means when two springs where the ends are connected to each other. Now, a brief overview of the system. We used a spring that had a relaxed length of 10.8 centimeters and a mass of 59.18 grams. In order to finally we let the spring oscillate with a mass on it, and we used a procedure similar to the one during lab 4, and we K is equal to 35.593 newtons per meter. Now, as to the tracker analysis, uh, I tracked the movement of the top of the spring as well as in order to get more accurate uh, analysis of the movement of the spring as a whole. And because the distance of the top of the spring and the bottom of the spring allowed us to notice when the spring would compress or stretch. Now, for the initial conditions, in order to understand how the computational model was built, we need to take into consideration that the spring we used, it was not an ideal spring, but a spring that had mass and a mass with a distribution with a specific mass distribution across the length of the spring. So in order to create the computational model, we had to break down the spring into smaller ideal springs that were connected to a mass that would represent the mass of the spring. And so in order to build the actual computational model, we had to realize that the system is in static equilibrium, and in order for this to be true, each spring must support the weight of all the masses below it. So therefore, we used this formula where for the ith spring, which um each spring is going to be the first spring, the second spring, the second and third spring. We use this formula in order to get the length of its spring. This is a combination model, the coding for the model, where the forces were taken into consideration as well as the weight and the Newton second law was used in order to calculate the velocity as well as the position update formula. These were the results that were obtained due to the experiment, and as it can be seen, the the top most of the data is very close to each other. So this means that the computational model resembles very closely what happened in real life. So the top part of the spring's real motion was very close to the predicted one, and this happens with the bottom one as well. Some possible errors for this experiment are that in reality the surrounding forces could be exerting a force on the body, especially the air force, the air resistance. As also we relied a lot on approximations for our data, like the spring's length. We used a ruler that had a really big error for measurement. And another error could be that the the precision of where the center of masses were placed on tracker could not be very accurate. as moving on to the further questions, our first further question is, what if we remove the hanging mass? So for the experiment, our spring was connected to a hanging mass, and if we remove this, this alters the distribution of the forces along the spring, and ultimately the forces acting on the spring would be purely due to gravity, as well as the internal spring forces. And the what does it mean question? Um, I wanted to focus on how important it is to take into consideration all the variables when constructing a combinational model in order to make it as close as possible to what happens in real life. Thank you for your attention on this experiment.